just to introduce myself, my name is Eran Danino. I'm the regional sales manager for Southeastern Europe, including Hungary. And for the one who doesn't know Radware, Radware is in the market, first of all, more than over 20 years in the market, and we are playing in the data center protection. Yeah, come join us. We are waiting just for you. So Radware is in the data center protection market. Data center protection means that we know how to protect your infrastructure, the data center infrastructure, but also the application. As today, in cyber attacks, you heard it throughout the day, how the attacks on the application are evolving, and we see more and more also in our field or in our area where we are protecting the data center, we see the shift to the application-based attacks. And the next generation is the attacks that are using artificial intelligence, AI. It's not that we are becoming more sophisticated and more smarter. The attackers or the bad actors are also using AI tools and AI technology. And you need to fight AI with AI. Okay? So just to move on, so I will focus, or today we are going to, not today, or this, session, it's not the whole day. I'm going to, focus on the four pillars here that you see. So the first one is the shifting threat landscape, how the attackers are using AI tools, and what does it mean, the sophistication of the attacks, the new regulations, as you see. You're probably familiar with NIS2 and DORA. What are the challenges over there and how Radware can help you with that? The hybrid approach, meaning an on-premise solution, but also you need the cloud in order to give more intelligence to the on-premise and give more intelligence over the attacks. It's crucial today. And what we are doing, not least, come join us. Yeah, good. Not less important is how we are lack of security engineers. Okay, we are not only in Hungary, we see that worldwide. And what we are doing in that space, and it's worth to wait until the end because we have something very unique over there. Together with me, by the way, is David Azar, is the engineer who is going to give you a little bit more insights how things are working in our technology, because I just know how to read presentations. He is the smart guy. Okay, so we start a little bit, what is the cost? We are talking about the attacks and the reputation and sensitive information and sensitive data, right? We don't want to lose our data, but there is also a cost for the cyber attacks. As you can see here, the average cost is over 2 million, okay? Other than the sensitive data or the data that is being stolen. Or you are being down, okay? So it's not only the data, but it's also the cost. So that's a little bit of numbers, the global and also in this region as well. And so what does it mean when we say, the shift of the attacks over the years? So it did start with, the attackers' motivation. What we see in the last, let's say, 3 to 4 years, where it started with the invasion or the war between, Russia and Ukraine. The motivation was different. So there are different motivations, some of them political, some of them religious ones. On top of that, there are all the attack tools that are evolving. towards the application, right? The growing of the attackers, the community. We see some of the hackers group, if you are familiar with No Name and Killnet, they are growing their community. And in the last 2 years, we do see the AI coming into the bad actors that are being used as their motivation to evade or to use special techniques with automation, how to bypass your defense mechanisms. So there is a challenge over there as well. So we did speak about the hacker groups, and we understand the political motivation or religiously or the financial. Okay, so there are different motivations for the attackers with different groups, and sometimes they are combining, you know, they are joining forces in order to have, you know, a more sophisticated attack, more volumetric ones, if we are speaking about DDoS. So these are the groups. Most of them probably you don't know. Anyone familiar with one of the groups here? I will not be suspicious about you if you know them, okay? Don't be afraid. So mostly I can tell you the differences are mostly the type of the attacks, okay? Let's say Anonymous Sudan or Anonymous Russia are mostly, all right, yes, come on guys. You didn't miss a lot, okay? So I can tell you the different groups. No Name are mostly familiar, or they are mostly known with application-based attacks, okay, more sophisticated ones. While Anonymous Russia and Anonymous Sudan, as you see here, are mostly familiar with or mostly known with more volumetric ones, more network ones, less sophisticated. Okay, this is what we see in our intelligence, our threat intelligence center, but not 100%, okay? You can see that Anonymous Sudan, for example, are doing application-based, but this is what we see, the differences between the groups. But these are the motivations in general. Let's move on because we have a lot to discuss and a lot to cover. This is just an example how one specific attack tool that you can get anywhere, okay? You don't need to be in the darknet. You go to GitHub, you download MH DDoS tool, and it gives you all what you want here. Okay, just for you, just for the example, how to do DDoS attack vectors, or a bot attack, or web application, or to bypass specific solutions. Okay, Google bot, how to bypass. Cloudflare, how to bypass Cloudflare. Okay, so within the same tool, one tool, you can launch all attack vectors, DDoS, network, or application-based, and bypass specific. Just an add-on on the tool itself. Publicly available, go to GitHub, search for that tool, and you weapon yourself with that tool. Another example of a tool, Wolf GPT. This is an AI-based attack tool that knows how to bypass CAPTCHA and use generative AI algorithm in order to attack your organization. Okay, so you see that it's not only presentation, this is a real attack tool based or powered by AI for the bad actors. Okay, and you can launch any of the attacks over there. So we do see the shift from the network to the application, and we do see the shift on the attacker's side, how to utilize or how to improve their attack tools in order to use AI technology. These are the challenges, okay? I didn't speak about how we do it and what we do in order to solve it. These are the challenges that you need to know, unrelated to what technology you have in order to fight it. But the need is you need to fight AI with AI. You cannot do things manually with AI because it's all automatic, very sophisticated, nearly impossible, okay? The second point, like I said in the beginning, is the regulation, right? Nobody likes the regulation, but it's there. We need to follow them. We need to be compliant. So DORA and NIS2 are the most, let's say, relevant ones. And so you need to ask yourself what you are doing in order to be compliant with those regulations. And Radware is there, okay? Just in any of the solutions that we are providing, we know how to be compliant and how to help you as an organization to be compliant with those regulations. Okay. The point number 3 is the hybrid cloud environment, and we see that a lot of organizations are moving to the cloud, but some organizations, or most of the organizations, are still maintaining on-prem solution. Okay? Some organizations, I can tell you, one of the airlines that we just closed the deal with, they moved their application to the cloud, but not all of them. The critical applications they wanted to have high visibility or high risk, they moved them to the cloud. And let's say non-critical applications stayed on-prem. So they have 2 WAF solutions, one in the cloud and one on-prem, both of them from Radware, on different, let's say, different reasons why to move in the cloud. They use the critical ones in the cloud and non-critical on their on-prem. So these are the, let's say, the expanding or the solutions where you need to maintain. And it can be public cloud as well, by the way. Okay, so if you move your application to AWS or to Google Cloud or any other, you need to make sure that you are protecting your applications also in public cloud. Okay, so that's the shift. It can be private cloud as well. Okay. Last but not least, like I said, and we are still with the challenges. We have a shortage or lack of security engineers that are able to manage or to oversee the security events. Okay, it means knowledge, it means expertise, and it means the amount of engineers that you need to hire. This is a challenge, right? It's globally, it's worldwide. We have it as well in our SOC, lack of engineers as well. So it takes time to educate them. If you hire a security engineer today, it takes time until he's up to date with all the technologies, all of the solutions, and you need to maintain this education over time. So this is a challenge as it is, and it's going to stay like that, I guess. So what is needed? What is needed to stay ahead with all these 4 challenges that we just explained or described? The first is the intelligent security. We talked about how the bad actors use AI. So you need to fight AI with AI. You need an intelligent, 100% fully intelligent security platform. You need an integrated platform because you need to protect, the cloud or the application as well as the network. Okay, you need all layers of protection. You need the DDoS protection, you need the web application, you need the API. API is not less important than it's part of the application, so you need that as well. And you need the posture management as well. Also very important. I will touch based on that as well. You need to protect your application in the data center. You need to protect your application in public or private cloud if you have. And you need to have the expertise in order to fight against these kinds of attacks. Okay, so this is what you need. Not a lot, but very, very sophisticated. Let's move on. So this is just to visualize what we just said. You need the intelligent security, integrated platform, consistent protection, and expert defense, all AI powered with algorithms, LLM, okay, and machine learning. I can tell you a secret that Radware, with our behavioral DDoS mechanism that we started developing 20 years ago, it's the first machine learning in the market. Okay, we didn't use AI back then because the term wasn't there, but it's the first machine learning that I was proud to be part of. Okay, so it's the machine learning, layer 3, layer 4 DDoS, developed 20 years ago. Obviously, we improved it over the years, but we started 20 years ago. So we did introduce in the last year Radware Epic AI. It's AI-powered intelligence and generative AI algorithms that helps your organization to fight against these kinds of threats that we described. Also, attackers use those tools. So if that's your data center, just to cover what we are doing, okay? So you have the DDoS attacks, network-based. You have web DDoS that we see in the last 2 years as a huge amount of them all over. These are layer 7 attacks that targeting, your specific application. It's not your network that is going down. You need the API protection. You need web application firewall, bot manager, also anti-bot solution to cover, the bad bots, right? You want to allow the legitimate ones, but close all the bad ones. Threat intelligence, to give insights from all the deception network that we have over the globe in order to fight those kinds of attacks, all powered by AI algorithms. Okay, so in each solution, just to make sure that I am clear, in each solution we have AI algorithms. Okay, in each solution we have AI algorithms. In the DDoS we have its own algorithm. In the web application firewall, there is an AI. In the API protection, there are AI algorithms. But overall, we are using a cross-engine AI algorithms in order to make it an ecosystem. Okay? An integrated solution. Okay? Obviously, each one of them is one solution. Okay? But if you get everything in the big picture, you want to have all the solution from Radware, there is also, insight to have an AI algorithm to cover all of the solution, to make it one ecosystem, one solution. Not specific algorithm for specific solution, although we have that as well. Okay, so this is just another view, how to cover the AI with all of the solutions. Okay, account takeover, next generation firewall, API protection, with business logic here, and ASPM as well. Okay, ASPM, application posture management, application security posture management. So how many of you know what ASPM is, application security posture management, right? But you know what it is? You know what it means? Anyone? Very good. Okay, so ASPM is application security posture management, and it means we'll start with, a little bit, I will take it one step back. Every application, there is probably there is the pre-production. Pre-production means, SAST and DAST solutions that are in the market, others as well, application testing, but this is the most common one. DAST, where you basically test your application code before you are going live or before you are going into production, right? That's the pre-production. Okay, these are the solutions that are in the market, the pre-production. The production, the real-time, or sometimes called runtime, these are the web application firewall, anti-bot solution, web DDoS, mobile protection, API protection. These are real-time or production solutions that analyze real-time traffic and fight against attacks. If there is an attack, we know how to stop it, right? As opposed to pre-production when we search the code. It's not the application itself, but the code, and looking for vulnerabilities. Here I'm looking for vulnerability or looking for attacks in the transaction itself. Packets, transactions, okay? So I have the pre-production, I have the production, okay, with each one of the technologies. I can tell you a secret that this is not 100%, and this is not 100%. So the ASPM, give you the insight here, the ASPM comes between, okay? It comes between to cover what this one is not doing and this one is not doing, okay? Basically, ASPM means that I'm analyzing real-time traffic, real transactions, in order to find vulnerabilities or potential vulnerabilities in the future. Okay? Here I'm searching the code, right? I'm searching the code to find vulnerabilities that are existing in the code. I know this code is not 100% developed. I'm searching vulnerability and I don't know how to fine-tune the code. Here I'm searching real attacks that are happening as the traffic flows. In the ASPM, I'm looking for potential future vulnerabilities based on real transactions. On the real transactions, I have all the HTTP headers, HTTP metadata. And I know how to build the picture of the application. And based on that, I am able to find potential vulnerabilities in the future based on scoring. Okay? This potential vulnerability is 20%, let's say, with risk. Or this is 80%. Okay? And it looks somewhere like that. Okay? All the connections between the libraries, between the transactions, and I know how the application looks like, and try to find the vulnerability. And then I can use the web application firewall, for example, in order to create a filter to stop that future vulnerability. It doesn't happen now. It's not happening now. It's in the future. Maybe it will happen, maybe not. But I have the filter already in my web application firewall that if it will be, I know how to stop it. Okay, and obviously the applications are dynamic, changing all the time, so the ASPM needs to search the application and look over and over again for those vulnerabilities. Clear? All good?
Yes.
No, I want it to be clear for you as well.
It's clear.
All right, let's move on. API protection, also based with AI algorithms. We know how to, we utilize our API discovery in order to learn your API application. Fully automatic, okay? Another point is the business logic attack. Business logic attack is, it's not only that we learn your API, we learn the sequence of the transactions itself, or the API calls, what we call. So we understand the intention of the users. Okay, it's in the user level. We are not analyzing here transactions. So it's the business logic. There is no how to say, in web application firewall, you are looking for a malicious content, right? A malicious transaction. On the business logic attack, there is no malicious transaction. There is maybe a malicious intention, and that's what we are looking for. The business logic, it's more business rather than a malicious transaction. It's more malicious intention. And that's where we are applying, you know, the security policy, the provisioning of the, and obviously the schema enforcement, okay, in order to stop these kinds of attacks. We will see that in David if we have time. But this is, you know, how it looks like, okay? A business logic attack, how the connectors, what is the sequence of these transactions, how they look, and what is the intention behind those API calls. Because this is legitimate, and this one is legitimate, and this one is legitimate, but maybe the sequence, maybe it doesn't make sense to get, to make this API call and then this one, or this one. Okay, the sequence doesn't make sense, so it looks suspicious. Okay? Because this one is legitimate, and this one is legitimate, and this one is legitimate, but the sequence of those, how you request those APIs, this is what triggers our algorithms. Clear? Good. The next one is the SOC expert. Remember the point number 4, where we don't have enough engineers and we don't have enough knowledge to cover all of the solutions in the market? We recently introduced AI SOC expert. Okay? AI SOC expert means an AI engineer, let's say, that can fight against resolutions of incidents, okay? It's just, if you know WhatsApp application, there is a chat, you know, a chatbot when you are chatting with an agent, a virtual agent, so that's the same thing. There is a SOC expert that you are chatting with or asking questions. I have this kind of attack. What is the filter or what is the mitigation filter that I need to place in order to stop this attack? And that virtual agent or SOC expert will tell you, this is the filter that you need to do. Okay? That's an example. This is the attack. Okay? The footprint, the real time. Here you have a SOC expert chat that you are chatting with your agent, with the SOC engineer basically, and he will tell you the analysis, and he will tell you this filter will block around 57% of the total traffic. Okay? And that filter is created by this SOC AI expert. Okay? There is no security engineer behind it, a real one, a human one. Okay, so he recommends a filter that you are able to place as a rule, as a filter in our DDoS machine, for example. Okay, so let's say that the attack is fully mitigated with our DDoS solution, but not 100%. Let's say 95%. So you can ask the SOC expert, what is the filter that I need to place in order to block 100% of the attack? So we will tell you this filter that you need to place in our defense pro. This is the DDoS solution. This is the DDoS device. Will block. You need to do this kind of filtering or fine-tuning. Maybe be more sensitive on the algorithm. So you just push a button. Also, he recommended you, and you are able to push a button and send the policy or the filter to the defense pro itself. It can be fully automatic as well, but sometimes maybe you want to review the recommended filter. Okay. So these are the challenges and the solutions from Radware. We did it very fast because we are short on time. Just to tell you the big picture, where we are going. So all of the solutions with Radware can be a device, a hardware device, a virtual device, can be a cloud service from Radware. All of the solutions can be either hardware, virtual appliance, or cloud service, and can be any other vendor or solutions you have in the market. These are the enforcement points, we say, or enforcement tools, right? Because they are, let's say, non-intelligent one, right? There is a device, can be a load balancer, it can be a DDoS device. They are intelligent, but they don't have the insights of a global view, right? Because if I deploy our DDoS solution in your data center, in your physical data center, all it sees is only your data center traffic. It doesn't have a global view, okay? So these are, let's say, non-intelligent one, okay? We call it. Then there are the cloud, all the solutions from the cloud that provides an insights on the global level with a lot of feeds to the solutions on-prem, okay? Because in the cloud, I can have a global view, okay? Then I have another layer on top of it as a cross-platform engine or a cross-platform fabric, where I provide a cross-engine solution, okay? Because I can detect an attack on a DDoS level and protect it with an API because I want to update all the engines with this kind of threats or this kind of source. Because, you know, today the attackers are not, you know, wake up in the morning, I want to attack this organization without mentioning any names. And I will do it only network DDoS or only application DDoS. They are coming with all the tools and launch all of the vectors of the attack. So if I detect an attack on the web DDoS in my engine, I want to update all the engines with those sources that are suspicious, that are being used to generate the attack. Okay, I don't want the API now to detect another attack with the same source. Okay, if I detect the source here, I can block all of them in all of the modules. Okay, so this can be done with the cross-platform engine. Okay, and the SOC management core, on top of it, I have the SOC AI expert, a SOC engineer, a virtual one, where I can basically improve all of the solutions with recommendation how to block if something is wrong. Okay, and it can be fully automatic. Okay, integration, analytics, insights that the SOC engineer, the human SOC engineer, sometimes takes hours to generate. This virtual one or the SOC expert, the AI SOC expert, will generate it nearly real time, let's say. Okay? So that's the overall. I will move fast because I want to cover the technical part. Yes, David. The web DDoS? Yeah, your turn. Yeah.
Hi, my name is David.
Any questions? Any questions?
Many, but later.
Many
questions, but later.
Later.
Many questions. You have only one.
Yeah.
What? This is a quota? Only one. Okay, thank you.
I was joking.
Me too.
All right. So David will cover the, let's say, two highlight solutions from Radware: the web DDoS that we are using AI engine, and and API protection. Okay, more truly into the.
Okay, thank you, Eran. Anyone guess how many times Eran mentioned AI? Too many, yeah, too many. So I will not cover any AI. I will take other approach, okay, machine learning, and very accurate algorithms, but not AI. We have so many AI. Actually, some of the, we get just got a quote from the independent researcher. I think it was OAM or maybe Spark that said, Radware is the only security solution vendor that proved that he used AI for mitigation. All the parts that Eran said really trained model of AI, okay? They know the baseline, know familiar with your traffic, and give precise solution for this. Okay, but let's cover the layer 7 DDoS, web DDoS, tsunami DDoS, so many names, but they're actually high rate RPS, HTTPS flood, you name it. High rate RPS, request per second for web application. Okay, I guess I know I'm working mostly with the Israeli market, and we got a lot, huge amount of web DDoS. I guess that you are also suffer some of this attack in the past 3-4 years, and it's come and grow with MH DDoS and all GitHub open source tools. So, what is the unique of the Radware that we are doing different from all other vendors of the cybersecurity? Radware is, in our core, is algorithm-based company, okay? So we are doing it differently. We don't do like manual changing, not do just rate limit, behavioral. We do it like we take a look of the attack, and we try to figure out what differentiate between the attacker and the legitimate users. Because the traffic is going past through Radware Cloud all the time, we know the traffic, we know your clients, we know how it's work, okay? So we take two baseline. One baseline, actually it's very simple, it's just requests per second. We know for specific application how many requests per second there is all over the months, the day, the night, we see, and we track it all the time. We track it with, of course, algorithm, not AI. So this one is the first one. The second one, your slide is not good. No, not good. Okay. we have two threshold. The second one is the application behavior. Okay, this is the sweet spot. The application behavior. We know the difference between, again, the attackers, what kind of tool they are using, if it's MH DDoS, Mega Medusa, so on. There's some signs, okay, some signs in the header of the layer 7, of the HTTP, some signs that focus the attackers for the different proxies they are using. Okay, they can go 100 proxies, you can go 1,000 proxies. We know the signs. And when we know the signs, we can implement in 0 day, okay, automatically signature. This is some kind of signature, you can see it here. We take up to 60 fields in the HTTP header, okay, and combine it. The longer, the better. The longer the signature is the better signature, and this is how we can mitigate it, the attack. All of this it's working from the start of the attack up to 5 seconds. Again, 5 seconds. 5 seconds, and this signature is applied on the traffic of the application, and it's working. Okay, we start like in 2 minutes to implement it, but our customer want shorted to mitigate it, so we go to 30 seconds, and now we are 5 seconds. Okay, 5 seconds from the start of the attack, we can apply the signature. Okay, we can get a lot of example, but if I saw in 3, that's it. Okay. So, okay. So this is without AI. Okay, I thought I can see the threat intelligence also, but those numbers are real. Okay, we saw it. We saw 15. We saw 16 million RPS. We saw the longest layer 7 DDoS attack was 3 weeks. Okay, this one goes like, I don't know, 10 hours, but we see 3 weeks. And when the attackers group want to fight with the company, they do it. Okay, so thank you, Eran, and thank you for joining.